Okay, so yeah, so hello everyone. Welcome to Ask Seminar Series. Today is our first seminar this year, and we are so happy that we have so many folks been presenting here, and also our director Nas Peter is also here, and he will be introducing the speaker. So before the speaker gets started, I will have our director Nas Peter to introduce the speaker.
Hey everybody, and welcome to this ESIG in-person seminar, the first, as John said, the first of the semester. So it's nice to see people here, and it's always nice to have in-person seminars. I mean, not to say anything bad about the online seminars. We love them, but it's nice to have people visit us and to have people show up as well. So today, it's a pleasure for me to introduce Jen Delamere, who is a physicist from Hopkins, actually. So from here, from just up the road. But she has spent most of her career in Alaska. So after her degree at Hopkins, she did a PhD at UAF, University of Alaska Fairbanks. And you stuck around there.
Deviation in the middle, but mostly, yes.
Where she is now the director of something called the Geographic Information Network of Alaska. And they are working on satellite data, on nested satellite data, and getting that out to users both up there and down here. And you are here because you wanted to visit us, because you do have some sort of affiliation with us.
This year? Yes.
Yes.
That's why
I'm here. So we're happy to have you, and you and I will be talking later this afternoon, but we look forward to hearing what you have to tell us about your work.
Okay.
Floor is yours.
Thanks. Well, thank you for that introduction. What time zone am I in? I guess it's lunchtime. I'd like to thank John for arranging the seminar for me, and for Kate for getting my agenda all sorted at the very last minute. You might notice me with some paper up here. It's because I don't always deal with time zone changes well. Alaska's 4 hours behind Maryland. We fly overnight to get to the lower 48. And I foolishly decided to change up my slides flying out, which has now made a PowerPoint nightmare for me, so bear with me. But the notes, I really just wanted to make sure that I say it pretty clearly that GINA at the University of Alaska Fairbanks, our mission is to make polar orbiting satellite data from NOAA weather satellites accessible to weather forecasters, hazard managers, weather modeling community, and yes, the public, in near real time. And so for us, that means as soon as a JPSS satellite has flown over Alaska, we're getting the data and getting it out. So I'm going to go on a real long rant about all these great things that we do, but I want to be clear, I'm not a subject matter expert on everything I'm about to show you. Those subject matter experts are actually here in this room, and I'm looking at many of you. My job as director is really to facilitate connecting researchers with people in the operations world and vice versa, all the while keeping information flowing to and from the public arena. So, of course, this is a last-minute addiction. You can see the timestamp. That's actually 6:32 this morning in Fairbanks, Alaska. It seems I couldn't escape the weather. So home in Fairbanks, we have a winter weather advisory, 18 inches of snow, 30-mile-per-hour wind gusts. I come here thinking I'm going to get a big vacation, and no hazardous weather conditions in Greenbelt. Morning commute is snarled, schools are closed, so tropical weather nowhere in my future. So feel free, I encourage you all, there's a ton of QR codes on this presentation. I don't mind if you get your phone out. akclimate.org is a live webcam, sort of from not quite my office, but close enough. You can see, well, depending on your perspective, there's a radome over here in the corner, and that's one of the antennas that I'll be talking to you about today. So you usually start out one of these things with thanking people. Well, I have tens, hundreds, perhaps thousands of people to thank. So I'm just going to name offices, the NOAA National Weather Service, Alaska Region Office of Observations, all the cooperative institutes, CIRA, SIMS, SUCCESS, SPORT, NESDIS, NASA Goddard Space Flight Center, JPL, the Globe Implementation Office, many more collaborators across other federal agencies like Department of Interior. But I really want to make a shout out to my UAF team. Without a whole lot of staff, other professors and students, we wouldn't be able to do what we do. So thank you very much. Now, again, I just mentioned I changed up all my PowerPoints. So what I'm going to do is start with a presentation summary. Why am I here? I'm here to collaborate. So if you get lost in all these slides and everything I'm going to say, that's the summary. I'm here to tell you what we do. And if I mess it up, go to our website. There's lots of links. But please reach out to me either in person or by email, because if you have an idea for Alaska or the Arctic and it involves LEO data, we want to help you be able to communicate with those that are, in the operational world in Alaska. So I do this every single presentation. I talk to you a little bit about Alaska. Has anybody in the room been to Alaska before? Excellent. Okay, so usually I say, oh, Alaska's so big, Texas, California, Montana would fit within its borders. Today I'm going to say perhaps I looked at Dr. Google, who told me about 54 Marylands would fit within Alaska. Depends on whether you count water, land, however you want to look at it. So Alaska's kind of big, as you can see, reference to the lower 48 here. So I come from New Hampshire. I grew up in the 70s and 80s. Everything's wicked big, wicked cool. So Alaska is wicked big and wicked remote. And I always like to tell a new audience sort of by the numbers. There's 730,000 residents of Alaska, about 585,000 square miles of land. So do the math, about 1.3 people per square mile. If you applied that population density to Maryland, I think there'd only be about 12,000 residents in the state of Maryland. I don't know if I quite did that math right, but close enough. We have around 350 communities, only 150 which are actually incorporated with the local government. So 250 communities are unincorporated in rural Alaska. So, well, we got lots of stuff up there. We have active volcanoes out along the Aleutian. So right at where the Legend Bar is, 5% of the state is covered by glaciers. We have wildfires every year that can burn up to 5 million acres. So if you're not sure what an acre is, well, there's 365 million of them in Alaska land. So that's, big space again. We have a lot of weather phenomena that happens like typhoons out in the Bering Strait or landslides down in our capital near Juneau. If you need a stat to take home to your kids, 1 moose per 3 people. So that's a good one. You can tell your family what you learned at work today. So now a little bit about the infrastructure where I go again. Oh, Alaska's not like the lower 48. So 82% of those communities I mentioned are not on the road system. Roads are in red. There's a lot of the state uncovered. So you can see where the satellite piece is going to emerge here. 60% of our communities have no local fire department. So you can see how important satellite data for early detection of wildfires. It's really a game changer for Alaska. 90% of our state is underlain by permafrost. So there are a lot of communities that have no plumbing. Yes, that means outhouse and other ways of getting water or using the restroom, taking a shower. And not to be, too light, I will say we do not have Dunkin' Donuts or Trader Joe's. So perhaps I came early on Saturday night, so I might have a coffee, visit a Trader Joe's. So now let me tell you how Alaska's not like the lower 48 when it comes to weather. So sparse radar coverage. We have 7 weather radars, some of which are terrain blocked. So I think, again, Dr. Google tells me we'd need somewhere around 30 to 40 radars to be like the lower 48. And if you don't want to be terrain blocked, you're going to need more like 50 or 60 radars. So we have a long way to go before weather radars will really give us great coverage of the state. And as far as upper air stations, how many balloons do we launch? Well, there were 13. I have to say I'm not quite sure of the count right now, but there are only 13 upper air networks where we can launch balloon from. So again, satellite retrievals from things like NewCaps, where you can get vertical profiles of the atmosphere, really, really key to how forecasters can do their job in Alaska. Okay, now I realize I'm going to be getting into dicey category. So how many of you in this room are regular users of the geostationary satellites? Okay, great. So geostationary satellites are an incredible tool. Minute by minute observations of the lower 48. It's power throughout the equatorial region, the mid-latitudes. It can't be matched. However, as you climb north in latitude into Alaska from Juneau, which they say is the sweet spot between Geo and Leo, to Anchorage to Fairbanks to all the way up north in Utqiagvik, the steep look angle of Geo really causes quite a degradation in how the pixels look. There may be some parallax issues. And as you get further north, there simply is no Geo. So if you're out on a ship trying to navigate the ice flows, you're really going to need a different type of satellite. So now we're going to get into the harder matter here. LEO, low Earth orbit satellite data from the final frontier, which I had to look up where that phrase actually comes from. I guess it's Star Trek, 1960s, to the last frontier, and talking to you a little bit about what we do at UAF GINA. I'll call it the Alaska Direct Broadcast System. So just a review. LEO satellites for our weather orbit the Earth at about 100-minute orbits, 500 miles above the Earth's surface. You get global coverage twice daily, but in Alaska, you get a whole lot more views from LEO. There's a technology, especially on the JPSS satellites, called direct broadcast. I don't know if this phrase means much to people, but there are 3 ways the JPSS satellites transmit data to Earth: S-band, Ka-band, and then X-band, which can basically transmit to little antennas, small regional antennas. And as the satellites fly overhead, they're directly transmitting to these ground stations. And that's where my group comes in. We own 3 antennas in interior Alaska. Our oldest one we call Big Dog. It was installed in 2001. My husband's office looks right out at it, and Denali's actually in the back there. 2014, we put an antenna out at the NOAA FCDOS station, just about 30 miles outside of town. And in 2024, we put in a brand new antenna. So right now we're receiving, our count is back at 8 satellites, you can see, but of course with NOAA 19, 18, and 15 just retiring, Terra is no longer transmitting to us, of course. So our satellite count goes up and down, but this year we're bringing on MetOp-SG A1 and GOSAT-GW. So I just wanted to show a quick video, thanks to my technology people over here, of us installing the new antenna last year on UAF's campus. So it took a crane to lift this thing up. The crane operator cannot actually see the top of the roof, so there's someone up there with a radio. It's all done without any technology. It's voice. Up goes the antenna, which is about 3 meters, and then this giant radome gets lifted. I was on door duty. I did not have anything else but watch the door and make sure no students go see what's going on. The lifetime of this antenna is 25 to 30 years, so it should see the JPSS satellites, through their duration. They actually let me climb up on here. I had to do a lot of safety training, and I'm not going again. There's a 23-foot parapet I had to climb up, and I was like, I got to do this, but one and done. That's why we have special engineers to handle this. So I love that video, and I don't get tired of watching it, and now this is where YouTube comes up. Thanks. So what do we see? This is our coverage, a coverage map. So essentially we can see over the Kamchatka Peninsula in Russia, over into western United States, north up over the pole, south to the Gulf of Alaska. For the JPSS VIIRS instrument, we get about 24 passes a day up in the red. And as you come down into the Fairbanks area, middle of the state, around 16 passes, and 6 in southern Alaska. And again, this is all 3 JPSS satellites combined. What do we do with all that data? Well, we process it at UAF. We have a big processing system, and it goes out to people all over the world. We have a lot of research to operations, and there's people in this room that we work with to test new products. And then we hand a lot off over to the Weather Service when things become operational. I want to highlight here that none of this work could be done without the University of Wisconsin CSPP software package. They write all the direct broadcast software that allows us to process data. And as products go from research to operations into operations, CSPP takes over the code, and then it just runs routinely. And our goal is to be delivering data within 5 to 25 minutes of a LEO overpass. So active fire detections are a couple of minutes. Big imagery that we've formatted so it can go into Google Earth and other places can take 15 to 25 minutes, depending on how many passes we have coming in at the same time. There's a ton of data. If you're interested in using any of it, please just email me. I'll help you figure out how to get it. Visit our website. We have a lot of public API and web portals. We don't have fancy web portals. That's not really our business, but we can make sure you can pick up data routinely. And then data goes to the National Weather Service via LDM and AWIPS. And we're starting to build subsets of a lot of these products into Esri data layers. Products can mean VIIRS imagery or VIIRS sea ice concentration or OMPS maps, any number of products. And Esri is the way a lot of the federal government works. So really, what you get out of this? Well, you can see every hour of the day, weather, sea ice motion, heavy precipitation, river flooding, wildland fire detection and extent, smoke and air quality, volcanic emissions, aviation advisory with clouds. Pretty much whatever you want to see from space, you're going to be able to get through this direct broadcast system. Okay, great. Lots of data. Data's great. It's marvelous. But I was reflecting to myself, I've been in this job for 5 years. Why do I just love it so much? Because it's a little unnerving during fire season, I'll have to say that. And it's because there's a whole community that's built up around a regional system like direct broadcast. So again, on Friday, probably a poor choice, blank screen, talking to Hannah, who's in our group, thinking, oh, how do I want to explain this community? So blank screen, she said, well, let's put an oval on there, direct broadcast. Great. Then we stole a phrase from many others, but I hear Mike Pavlonis from NESDIS use it a lot, shared mission space. So that's like wildfire, snow, rain. What's the mission? What problem are we trying to solve? So then Hannah creatively, because if you leave it to me, nothing is ever creative, gave me this. There's sort of 4 elements that we use in our daily life. So whether it be research or operations, and GINA often is in between, we're interacting with the community, we do outreach, community needs, and while there are arrows that go like this, really they can point in any direction, but that got a little bit too chaotic. So I'm just going to leave it at this. We're going to keep working on this graph, but this pretty much describes my day and why I love my job. So the first thing I'm going to talk to, and this is where I'm going to definitely run out of time because wildfire, well, you just might have heard the NOAA day-long series on wildfire. Wildfire can take hours and weeks to talk about. So I'm just going to move through this a little bit quickly. So by the numbers, this is really the only graph I have. I know you can't read it. Numbers are too small. But since 1950, our biggest fire season was in 2004. Blue right in the middle there with 6 million acres burned. This pink here is 2022 is when we burned 3.5 million acres, but the record that fell that year is we burned 1.5 million acres by early June. That's a lot for Alaska. We can have anywhere up to 900 active fires. In 2022, we had several hundred. This last fire season, just to give scale, it sort of ranked number 22. We burned 1 million acres, 467 total wildland fires, about half of which are caused by lightning, but all the acreage that burned this past year pretty much is from lightning. And this year's largest fire was about 117,000 acres, but our largest fire in the past has been 1 million acres for one fire. You'll have to do the math. Acres to football fields. It's a lot of football fields. So trying this out for the first time, here's our little graph. So where are you going to start on this circle? Well, I'm going to start with the community. Community has many, many needs when it comes to dealing with wildland fire, but I'm going to use my favorite phrase, is it on fire, from the Alaska Fire Service. They want to know, is it on fire? Alaska's big. There aren't enough pilots or roadside drivers to report it all. I'm going to switch to my paper because I wanted to read a little quote here. So in the early days of wildland fire, is it on fire or not? Tools that Alaska fire managers have to answer were, as Randy Jant from the Alaska Fires Consortium noted, early wildfire detection in Alaska relied on keeping an eye on neighborhoods and on lightning storms. Much of the detection around the state was done by aerial patrols beginning in 1973. In 1978, the Bureau of Land Management had 12 aircraft dedicated solely to fire detection and another 6 smoke jumper aircraft, which often did loaded patrols after widespread thunderstorm activity. So this is 1980s, 1990s. I'll date myself a little bit by saying I was a working professional in radiative transfer in 2004. Maybe there are others in the room. I didn't really know about MODIS at the time or what it was doing with wildland fires, but it was really revolutionary. So MODIS was flying on Tara and Aqua. We got a lot of passes over Alaska. GINA had these direct broadcast antennas in place actually for over 30 years now. And we were working with the fire service, I think often by hand, running sort of fire detections back and forth, and maps were hand drawn. I think there are people in the room that can probably speak a lot better to this than me. So as time went on and really smart people started taking a look at satellites, the question comes up, can you get even better spatial resolution, more looks for Alaska? So if you're going to guess what instrument I might talk about next, it's going to be VIIRS. VIIRS is probably the best observational asset we have for Alaska. It's versatile. It has just so much functionality. It flies on all 3 JPSS satellites, so we get lots of passes a day. It's got visible and thermal channels, so we get day and night monitoring. Its pixel size is fantastic, 375 meters for the I-bands. Now, I just wanted to show this with wildland fire. So this is an example of at high latitudes how with the day fire RGB, you can really see how fire perimeters change. If you want to look at intensity changes with the perimeter, you can use the shortwave IR I-band. So you're really getting a good look within the fire. And I don't want to knock GOES too much, but when you get farther north, the pixels just get bigger. So they're a kilometer, 2 kilometers or greater. So really the VIIRS pixel resolution is incredible for Alaska. And the other thing, at least with wildland fire, from VIIRS, we can quantify fire characteristics like fire radiative power, which helps to tell people, is it a low intensity fire? Are we at the leading edge? All the things those wildland fire managers understand about how fire moves on the landscape. So again, I'm speaking a little bit beyond my depth here, but in 2014, Wilfred Schroeder and more, and some in this room, were working on VIIRS active fire. So the research really was happening in those early years with SNPP being launched, lots of great minds on the problem. And we were able to put incredible dots on maps to help fire managers in Alaska. This is a video. I don't know if you can play my video. This is the 2025 fire season, all the active fire detections, just to show you what fire on the landscape look like. As we move through June, lots of lightning into July, it's all over. Then it rains, gets cold. We're wondering, when does it end? Well, pretty much in August, like it happens many years. So you'll notice some dots that might have occurred on the north slope. That's because we see, if there's a gas refinery, we can see garbage dumps burning. That's what VIIRS is great at doing. You can advance the next slide. I want to compliment Curtis Seaman, Bill Line, and a number of others, many others who have worked on putting together incredible satellite imagery, multispectral for fire weather applications. There's a series of 6 images from VIIRS that the Alaska Fire Service likes to have. My fan favorite is the Fire Color RGB. These are all sent to the Fire Service every pass of the day, every day of the year. True Color RGB is a great one because you can see smoke with it. It's like what your eyes would see from space. And if you can follow this QR code, we have a lot of training materials on these products, so I'm not going to go into detail, but if you can remember gina.alaska.edu, you'll find all of this. Now I'm going to get out my paper again because I said to Curtis Seaman at Sierra, I'm like, I want to show our new VIIRS GeoColor product, and I can never remember what you tell me. So he wrote to me, and I quote, GeoColor is one of the most popular products of the GOES-R era. It combines true color imagery during the day with multiple layers of information at night. But VIIRS GeoColor, which we're now producing at GINA in near real time, has advanced over GOES GeoColor in that we have a day-night band which detects light emissions at night from fires, so we can provide real-time information from fires, city lights, power outages, and that really can help detect smoke and volcanic ash at night under sufficient moonlight. So thanks to Sierra, we have this new product that we'll be distributing over the summer. And again, big QR code, there's all kinds of training manuals on this. And we have some new products in the work, a day-night fire temperature, crisp-based imagery to get a handle on water vapor. So these are all things coming down the pipeline in the next year. So when it comes to operations, we work with the Department of Interior, and we send those 6 images and all the fire detections via an Esri app into their system. It's got a name change this year, but it's a Wildland Fire Information Map Series. This is available to the public. So there's lots and lots of people looking at red dots on maps when the fires are encroaching Fairbanks or Anchorage. So the cool thing about this is it's sort of a shared common operating space. The Weather Service, the Fire Service, and the public are all seeing the same information at the same time. So we're not having to sort of second guess what other people see. The VIIRS imagery, again, another QR code, but you can find all this. The map app is great. You can move layers around so you can overplot where the last lightning strikes were, the perimeters, the fire detections, and this is all available to the public. Well, this is a winter image from a few days ago, but you can go down, pick the images you might want to see within certain time frames. They don't last long, a couple of days. This is just a beautiful imagery of Alaska in winter. So here's another intersection where community and kind of operations met. So operations kind of said back to the community, and which includes us, when are these satellites coming overhead? So we built a layer for them to embed in their Esri web service, which tells fire managers when they can expect the next fire detection. So they're not always waiting for the next pass to come over. So there's a window of time they can go in and come back and say, okay, here come the next detections. So is the system perfect? No, that's why we all still have jobs and there's lots of things for us to do. So every once in a while, we'll get an email, or BLM will get an email saying, is VIIRS still working? There aren't any hotspots and we know there are fires. Well, VIIRS detections have some limitations, and clouds and smoke can hide active fire from VIIRS. So there may be no reported detections for a couple of days on end because there's clouds overhead. Maybe it's too low intensity to fire, so it's not going to be picked up by VIIRS, but it's still working. And then there is a gap in coverage in the local evening from about 6 to midnight. There are no JPSS satellites overhead. So what am I going to tell you about now? I'm going to try to address this one. What happens? Can we push our algorithms any further to be able to see a little bit better with clouds and smoke, or maybe find slightly lower intensity fires? And along comes an incredible system. Okay, I'm a little bit loosey-goosey with my timeline here. Really, NGFS has been in development a long time with Dr. Mike Pavlonis. from SIMS and now NESDIS Wildland Fire Manager. There's this incredible system being built called the Next Generation Fire System. Has anyone heard of it? Great. Well, go on to NOAA's website. It really is being built or designed for early fire detection and alerting. The most important thing up here might be that it's sensor agnostic. This means as new satellites come online, it's not going to be a huge lift to pick them up. They can be ingested. This is going to be a GEO-LEO, or it is a GEO-LEO world we're going to be living in and mixing as we continue to develop this system. So we have deployed NGFS in Alaska. This is an example Mike Pavlonis put together from this summer. We can detect fires up to 7 hours earlier. That means an earlier, not quicker. I say that wrong sometimes, earlier. That means satellites are going overhead and an earlier pass using NGFS picks up a fire, and it could be 3, 4, 5, 6, 7 hours later before the VIIRS active fire picks it up. Not all the time, but sometimes. So this is really going to be a potential game changer for Alaska yet again, which is why the work of the cooperative institutes is so important. This is just a little story from this past summer. There was a tundra fire on the North Slope, so way up north, only burned about 2,000 acres, but it was picked up early with NGFS and made the big news because fires burning in northern Alaska isn't exactly a common scene. There's no trees up there. It's tundra. It's flat. Yet it burns. So straddling this world with research to operations, between NOAA and the Department of Interior, at this point, we are delivering the NGFS in sort of a development mode for the 3 JPSS satellites. We're grouping the detections in hours. They can be displayed a couple of ways, either by just a traditional dot on map or polygons. It's a work in progress for Alaska. This data is available publicly, sort of, but we're not really promoting it yet while we sort of work out some of the kinks. And an important quote from the Alaska Fire Service, Jen Jenkins, says that NGFS is great not just because the algorithm has evolved, but all the attributes of fire have evolved too. So you get this dot on a map, you click it, you can see lots of things about the fire, like which agency might be responsible for it, how strong is the fire, when did the pixel detect, when was the fire detected with satellite, and just a whole lot more metadata that's available to a fire manager when they click on a dot on the map. So what's coming for NGFS in 2026? Well, we continue to meet with that community. That's so important to get the feedback from the fire managers, from the people that will be using this data. Just this week, we're pushing a lot of this data into AWIPS in the cloud for National Weather Service IMETs so that they'll have the same data out in the field. So when they're out fighting a fire, they'll be able to see all this data. They have Starlink, they have other capabilities now, so they'll be able to see all these web maps. We're working on expanded fire training and an NGFS alert dashboard. So I also want to say that there's more than just where we fight fires. Alaska only has a 3 to 5 day food supply, so aviation is super important for Alaska. So if there's a fire and a lot of smoke, where can we fly? And this is a great project going on with Sierra YJ-NO. They are ingesting the GINA direct broadcast data, and they've built this cross-section for aviation. This means if a pilot flying between Fairbanks and Anchorage, they can go onto this app, put those locations in, and they can get a cross-section of what the ice clouds look like, and now smoke has been built into this. And this is in sort of the testing phase with pilots, but it's just another example of sort of R2O pathways, O2R, whatever you want to call it. I know there's fancy new names, but this is how we get this JPSS data to the public. Really important, communications and outreach. We have social media. We have a great student who's pretty good at it. We contribute in a lot of ways at GINA to the community at large, including a lot of public engagement. This is our student, Abigail Haas, an undergraduate that did a Science for Alaska public series, 130 people she spoke in front of, sharing her experience as an undergrad at UAF working with wildfire. And I think it cannot be understated the importance of we at universities, how we're interacting with the undergrads and the graduate students. I happen to love undergraduates. They're fan favorite for me. We have 4 working with us right now, and I try to give them a lot of visibility so that when they leave GINA and they're going out into the workforce, they have real experience on their resume. Also, we go out into the communities. So this is another example with fire. We went out to Bethel. We went into the schools in Western Alaska, just talking to the students about fire and snow, because when the snow melts, fire can come. So it's a really great part of our job. Our student Abigail built a wildfire behavior game, and kids loved it. So this is a great part of my job. I'm going to run out of time, so I want to make sure I just share a few more things. So I'm going to change mission space on you. So fire, but different perspective. Volcanoes and aviation. I stole this graphic yesterday flying out. As planes are flying over the North Pacific, of course, they have to worry about volcanic SO2 and ash clouds. This is a really hard problem. If Nick Krotkoff is online, I want to thank him. He has really put a Herculean effort into using VIIRS and OMPS to get more information to those that need it fast in terms of discerning SO2 and ash clouds. One of the community needs that has come up over the years, a nighttime coverage of North Polar regions. Data need it fast. As these planes are flying over, what are they flying into? So Nick and a large team did some excellent work. They published a paper, Day-Night Monitoring of Volcanic SO2 and Ash Clouds for Aviation Avoidance at Northern Latitudes. Turns out it works pretty well. They're a really smart group of people. And so this algorithm is now being applied at GINA and the Finnish Meteorological Institute to really give a good vision to SO2 and ash. And so I'm not going to have time to go through this all, but suffice it to say, this new data product has allowed the volcanic ash advisory centers to essentially do a better job at forecasting and maybe tailoring their warnings to aviation, whether something's an ash cloud or SO2, where it can be flown. And the communication part comes here. I got a movie. Because these types of stories get turned into story maps. Great training for meteorologists. And this was an excellent partnership with National Weather Service, with NOAA CIs, and of course, getting input from NASA with Nick Krotkoff, Vince Realmuto, and Can Lee. This story map isn't available to the public, but I can give people a copy if they want, because it's behind on a NOAA GIS portal. So I don't have a lot of time left, and I have some great members of the audience here that I want to talk about. This is where I got in trouble with my PowerPoint. I was really going to go all in on fire, but then it was snowing. So I got to talk about snow just a little, and I'll keep this brief. Again, the shared mission space. So this part of snow is about snow falling. Weather forecasters need to know where the snow is falling so they can tell you to stay home. So National Weather Service has responsibility for, weather advisories. This is the map of the 3, that is only 3 WFOs in Alaska. This is enormous. So blue, the Fairbanks office has to forecast for that whole blue area, 400,000 square miles. Anchorage is in yellow, and Juneau is down here in purple, and that's what I'm just going to briefly talk about now. They have an enormous range, about 100,000 square miles to forecast for. Much of their terrain has got water, crazy mountains. This is a slide from Aaron Jacobs in Juneau. Situational awareness is super important for Southeast Alaska, and their radar is terrain blocked. So some familiar names may show up here. Some incredible work has been done here between NESDIS, SESS, UAF, GINA, Sierra. All these players come into this, working on building a new snowfall rate application, really for global, but today I'm talking about Alaska. So I want to thank this group of people for the work they've done to really get a handle on improved snowfall rates. So this is a slide I received from my collaborator, Juan Meng, talking a little bit about the algorithm that's been developed. I don't have enough time to go into it. But operations, again, straddling this research to operations world, the average latency is 14 to 18 minutes from a satellite overpass to when forecasters get this information. Right now, it's being distributed to the National Weather Service Alaska region, but thanks to a fancy website, you can all access this in near real time for a number of satellites, and this is using the microwave capability. I didn't say that earlier. Then communication outreach. Well, students. We had a student write an article, and we're very proud when stuff like this happens because our student went on to become a NOAA Hauling Scholar. So we're very happy to get our Alaskans out into the world. And then social media. Again, I have a student left to my own devices. I don't know what TikTok is, kind of. Instagram, not on my phone. Facebook, kind of. But we have students that help me in the modern age. And so these are just some examples from this year. I'm not going to have time to talk about this, but snow falls, it drifts, and it blows. So this is a pretty interesting example of new work that's been done in the world of blowing snow, which is not what we experienced here today. Bill Line at Sierra has crafted some incredible RGBs with blowing snow. And the thing I want to point out about this one is we're in that communication and outreach phase now. We're working with the GLOBE program, the Globe Implementation Office and NASA to ask citizens to report their observations of blowing snow. So that's blowing snow that's sort of blown by the wind and lofted up higher, than a few meters or blown around as it falls. Another QR code, but this is pretty cool because we're having participation actually from all over the United States. You see blowing snow, take a picture with this fancy app, send it in, and Bill Line at NESDIS is going to say, that's blowing snow, and we saw it with VEERS. Drifting snow, useful. That's really good. It has other applications. So this is just a really neat example of how we straddle this world between community needs, research, operations, and outreach. I'm not going to have time to go through these, but now we have an app where people are submitting their photos. And then Bill is in the process of going now and looking at VEERS. And did we see these examples of blowing snow that citizens, everyday citizens, have just reported, hopefully safely? I do not want to comment on this person driving with a phone. I do not encourage that. So safety is always foremost. And again, there's lots of quick guides available on this. The next generation workforce, again, students are super important to us. We have 3 working for us right now. And Grace, she just graduated. She is actually maintaining our website. She has another job, which down in Anchorage, but she kindly helps with our website. And then she's very kind to me when I mess it up because I'm coming out here and I want to change something. And then I have to say, please unchange what I just did. But, students are part of our office. Fall, spring, summer. Also in Alaska, we host the Farthest North AMS chapter. And this brings together people from the National Weather Service, the military installations, students. This is us at Alson Air Force Base here. This is the event with all the people and the tables. That's right outside the National Weather Service Fairbanks office door. And we go to AMS and we win awards for our posters. Very exciting. And I just want to share one more video, which I promised my son I would stop sharing, but I can't help it every time I'm in a new audience. And this will require you to play it in a sec. So my son, he loves to climb mountains. It's very scary. He's 25. A few years ago, he climbed Denali, so 20,000 feet. I was doing work up on the North Slope. And it's a blessing and a curse to be able to see satellite data of what's happening on a mountain where your kid might be climbing. So he survived, everything went great. And then I made him put together a video for me because I was like, your mom was kind of watching from above. And more importantly than what his mother was doing, the National Weather Service puts out forecasts for climbers on Denali, special forecasts each year. And so that office is just like right next door to me. And I try not to go like, what's going on up there? But this is just showing that even though I'm here talking to you in this capacity as a satellite person or facilitator, whatever you want to call me, I'm also a parent. And these weather forecasts are so important for anything like today, keeping your kids home for school, or in some mothers or fathers' cases, you have a kid climbing a really big mountain. So I'm going to end with this 3-minute video that, yes, I forced him to put together. He didn't do this on his own. That sort of splices in some satellite imagery with his trip on Denali, and hopefully the sound won't be too loud and just about right. And this will be the end. Yeah, see, it's a long time ago, but too bad he's never getting out of this video, and I don't want him climbing anymore. So they took off from Talkeetna late May of 2022. They had a period of awesome weather. I don't know any of this because I'm up north digging snow pits at this time, but this is the forecast coming out of the National Weather Service. And this is their team of 3. Yep, don't look, boss. The Weather Service is putting out forecasts. There's a lot of smoke in the area because we had early wildland fires. That's a pyrocumulus. He took this from 14,000 feet, looking out at the Hog Butte Fire, number 182.
Rolling off 17,000 foot camp. There's the Audubon, Super Ridge. There's no oxygen up here.
Just turned 25 yesterday. He told us, my husband and I, not to alter the forecast. Send them exactly as the Weather Service put them out. No parent interpretation. None allowed. Had a beautiful climb, great weather. That's him. Still has those pants 5 years later, his best friend from high school. There was so much wildfire smoke in the area that when they got back to the base camp, they couldn't fly out. At 7,000 feet of base camp, there was just too much smoke in the Denali area to fly the plane. And yes, you can get emojis from your kid at 20,000 feet. I got the first one, that he'd reached the summit. So that just goes to show, you better take the YouTube off here, that weather forecasts and all the work you do here at NOAA CIs, NESDIS, Weather Service, universities, wherever you are contributing to the mission, we are a weather-ready nation because of the work you guys do. And with that, I'll end. Thanks.
Thank you. So we have about 10 minutes for questions. So I'll alternate between online and in person. Online people can type it in the chat. In person people can wave at me.
Snow forecasting products contribute to avalanche forecasting at all?
Yes, they do. I mean, the avalanche forecasting isn't necessarily done by the Weather Service, but they put out a lot of information. Our snowfall rate product is new and it's going into the Weather Service now. And so it's a great question. I don't interface directly with the avalanche community, but I'm sure they're doing that through the Weather Service. I want to be very clear. I'm a data provider. I'm not a data analyzer, except when I'm a mother and your kid's on Denali. Then I'm analyzing. But that job is really left to the avalanche centers and the forecasters.
Yes, thank you. Very nice presentation. 3 questions.
Uh-oh.
No,
Okay.
this is informational. You show the coverage of the antennas, and I wonder, do you receive imagery from other parts in the northern hemisphere? I mean, is it only northern Alaska or the western end of the Aleutians?
Well, that's a great question. So the University of Wisconsin SIMS, they deploy a number of these direct broadcast antennas. I don't have a map, sorry. That's what happens when you mess with your PowerPoint presentation. But they're all over the world and they're feeding into like the weather models. So And there's even an antenna in Utqiagvik run by Nesdis, although it's not operating at the moment. And then the Finns have a Finnish Meteorological Institute. They have one. There's one in Sweden, and then the military has a number of installations in the Northern Hemisphere where they're deploying these antennas.
Right, but that is, I mean, those are possible sources, but they're not necessarily easily available, like GINA.
The Finnish Meteorological Institute, some is available, and then SIMS, they make their data public. And if you're not sure where to get things, that's where I become the facilitator. I'd be happy to help. And actually, a goal of ours in the next year or two, there's a direct broadcast conference at UMetSat this year. I think that can be a lot done in this space of sort of meshing these antennas internationally into a better network.
Okay, and yeah, what I was wondering is, do you is the archive going all the way back to when JPSS started, or is just
well
real time?
I am not allowed to be a data hoarder, so we are very much near real time, 10 days. Although I have the series of 6 VIIRS images for at least 3 years. Now, however, you can go to the NOAA, and I'd be happy to share code, but you can pull the I-band data and make geotiffs now pretty easily through script. So I've been told that I don't get to keep all my data anymore. And then perhaps we've slid a lot of it other places, but it gets expensive to handle all this data, and it's not really our job. But these geotiffs are too pretty. I like to go back through them.
Right. I mean, one thing that I really like about GINA is that I'm a big user of Worldview, NASA's Worldview, but it's pretty deficient in coverage over high latitudes, and GINA offers something that Worldview doesn't. And with that regards, Worldview is very good in terms of historical imagery, and but the coverage in high latitudes is poor, so there is no other resource. And that's why I was curious about GINA having an archive.
Well, we have a little bit of an archive, but also I have some very good students that can pass you some code if you need.
Okay. Oh, the third question.
Oh, that's right. You had 3.
So
okay.
quick, no, you did show some level 2 data that you're starting to use and display, like the SO2 example. Are there any other level 2 products that you plan to incorporate in GINA?
Well, we have quite a few, and I didn't even get into the cryosphere stuff really today. But for example, with the University of Wisconsin and SIMS, we have a lot of VIIRS products for sea ice that are level 2 that are now going to the Weather Service. The volcanic SO2 and ash, that can be made accessible. So pretty much as the research teams come up with these level 2 products, the big things we're working on now are the Arctic weather satellite, microwave instruments, getting that data out, in level 2 products like the snowfall rate with Juan's team. So yes, there's a lot of level 2 products that I didn't even get into today.
There's an online question, actually 2. Hi, is there any work on trying to get vertical distribution of wildfire smoke? This would be very useful for aircraft and also very useful for evaluating and improving wildfire smoke forecast models, as vertical distribution is a big uncertainty.
Okay, let's see. So again, this is not my area of expertise. We do have, we are not retrieving the vertical profile of smoke at this time. However, we are working on column conversions of aerosol optical depth to surface PM 2.5. We also have the NuCAPS product, which is the vertical profile of temperature, pressure, and trace gases. But we work with the HERS smoke community, the whole modeling community, but we are not doing any retrievals ourselves of the vertical profile of wildfire smoke that I can remember today anyways. Cool. Great question, and please reach out to me if you have ideas or whoever's online asking the question.
And then another online, is this data also available in NetCDF or HDF5?
Oh, of course. That's our bread and butter, and we have a public API where we can send a script and you can go pull it from us. And it's published to our public facing server as soon as it's ready to go. So the other thing is, we don't have a army of people inspecting every single product as it comes out. So if there's an issue with like SNPP's geolocation, it might take us a few hours to go, whoops, that fire's not in that spot. But NESDIS is very aware of the way direct broadcast is used, and they've done a super job at helping us like know exactly if there's an issue with the spacecraft and we need to say, stop processing the fire data while a geolocation issue is handled.
Thank you. Was there a question back there? Any other in-person questions? Oh, the same person who asked about the net CDF. How do I get this script?
Well, first of all, you can just email satellite at, well, they can't see it, satellite@gina.alaska.edu. Oh yeah, okay. And I'll help work with you to figure out the best way. Also, we pride ourselves on being there for users, that is keeping the data near the users the way they need it. So if something isn't the way you want it to be, we can work with you.
Any other questions?
I was wondering if you could comment, you've talked about the breadth of working with operations folks and producing a whole bunch of products, and sort of a two-part question, right? Operations can be national, it can be international, it can be Alaska specific, it can be local government specific, and products can be sort of Alaska, all of US, global. I guess, how do you manage the different scales of engagement, and can you speak to sort of the philosophy of what products you're producing and the scales you're producing them on?
Sure. So we have all kinds of contract and award vehicles, to be honest. So with the National Weather Service, the Department of Interior, and with each of those contracts or awards we might have, we work specifically with the user. So for example, the National Weather Service in Alaska, we're partnering with SIMS to make sure they have the products that they need fed into the AWIP system just the way they need it. And we've helped design a menu system for the Alaska offices that say, here's your global products, here's your national products, and here's the sort of direct broadcast products. Go to this part of your menu system. And if anything's wrong with our antennas, because we are a small shop, they can always fall back on the national distribution of that very same product. So the software that we use is built on NOAA enterprise products. So when they have it set what they want, then it feeds down into the direct broadcast community. The fire service, they want data for the Alaska region packaged in a certain way. So we work with them to make sure that they get what they need. And because our antennas are regional, that sort of dictates its reach. Although for DBNet, we're feeding all this antenna data into the global models for weather. I'm not sure I've answered your question, but it takes a lot of personal engagement, and that's why my job is fun. So we know what the users need. We understand whatever vehicle we're using to exchange funding, and our job is to make sure that we meet their needs through their funding vehicle, whatever it may be. And with NESDIS, they encourage us. Part of our job is to make sure the public has these products. So for example, there's search and rescue groups out on the western slope or the western side of Alaska that will go pick up the VIIRS geotiffs, because can they go out on the ice that day if they're hunting or trying to drive an ice road? So the public gets this data too. And we don't have fancy websites, so you kind of just go, you find the time you're interested and you click and it can download. Like, that's it. Real Earth and Sierra Slider from the other cooperative institutes are a lot more fancy and have the big global view where they're stitching everything together, but that's really not what we do. So we're very focused on Alaska and the Arctic. Thanks.
Thank you. And it's 1 o'clock, so I think we're going to go ahead and finish up for the day. Thank you so much to Jennifer for giving us this great talk.
Thanks.
And thank you all for attending. This was our first seminar of the semester, so we're going to continue till May. So
Well, you came in the snow. Thanks very much.
Absolutely. Thank you. Quickly mute us so we're not